Hello, first year, and welcome back to physics. I hope you're all keeping well. What we're going to do today is just recover our energy topics we looked at last period and have a look at some new physics. So, you might remember in class we were carrying out the experiments on pages 2 and 3, and you should have completed your notes with all of the information that you can see here. The Bunsen burner and the tube, for example, we discovered that the energy change was heat to sound. Now, as we have completed these demonstrations, we are going to move forward to look at page 4 and page 5. On Firefly, you will find a video of each one of these experiments and also a copy of all of the notes that you need to write into your booklet. Experiment 1, okay, our electric light bulb. Our energy change there is electric to light and heat. The light bulb creates light, and because the inside of the light bulb heats up, we also have some heat present. Our electric bell, when the electricity goes through the wires and the little hammer starts to move and hit the bell, we have electric to kinetic to sound. Kinetic is the energy of anything which is moving. Our rattle, when you shake the rattle, and you will be able to see this in the other video, that is kinetic energy to sound. It makes a lot of noise. This is because the moving parts inside the rattle are banging together. Our solar cell, which we may have on our house outside on the roof, this takes in the sunlight and creates electricity that we can use in our homes. So light to electric. Our spring with a mass on the end. A spring can be stretched and it will return to its natural position. This potential energy is called elastic potential because of how it stretches. When you stretch the spring down with the mass, as soon as the mass is removed, the spring would go back to its original shape. A dynamo, okay, this is something you may have at home in a torch. You can wind up the torch and it will shine light. What we have here is a dynamo, and you can see this equipment in the other video that you wind. Because you are moving the handle round, this is kinetic energy. When you wind the dynamo, you create the energy which is needed to give light and heat. So our kinetic energy is turned into light and heat. Our battery operated train, you'll see the little train on our other video. It climbs up the track. This is using the electric energy in the battery to create kinetic energy which makes the wheels rotate and turn round. A loudspeaker is electric. Now this might be something you have on your phone when you play music on it. The electric from the battery or from if you've plugged in it to the wall is turned into sound, and the sound waves leave the loudspeaker. And finally, our microphone. You speak into the microphone. This is sound energy, and that is converted to electric. And the electric energy you'll be able to see in our video shows on the screen as a little wave with different amplitude and frequency depending on which sound you are making. So that was a quick cover of the experiments, but there is another video and these notes are saved into Firefly for you to copy into your own booklet. What we're interested in today is having a look at our experiment, energy, and conservation of energy. So what I'll do actually is make this nice and clear for us, and we'll label it together. So important for you to remember the principle of conservation of energy. Now this is something that comes up in the first year and it might appear in your class test if we do a class test. So this conservation of energy principle states that energy cannot be created or destroyed. It can only be changed from one form into another. Here we have a ball bearing at the top of the track at part A. Now, of course, if you let this ball bearing go, it will roll all the way round through the bottom of the track and up some distance on the other side of the track. So what type of energy does the ball bearing have at position A? It has gravitational potential because it's been lifted by a certain height off of the ground, giving it gravitational potential. As it rolls from A to B, it loses gravitational potential because the height is becoming less, and it gains kinetic energy. As the ball rolls from B to C, it loses kinetic energy and gains gravitational potential because it gains more height. The ball bearing does not reach the same height as A. Okay, so why would it not roll all the way around and back to the same position? This is because energy is converted to heat, and this heat is because of the friction between the ball and the ramp. If you think about it, if you've ever been on a slide and you are going down the slide and you put your arm down or your hand down, you might have experienced a burn, and you'll be used to calling it a friction burn. Now that friction burn is because your hand has rubbed against the slide, creating heat, and that, if you were to do it hard enough, would stop you sliding down the slide. So the same theory applies here. Because energy is converted to heat from friction between the ball and the ramp. Now in this experiment, it looks like some of the energy has been lost. However, we know that is not possible. When you rub your hands together, they get hot because heat energy is produced due to the force of friction between your hands. Because of this friction between the bearing and the track, energy has not been lost, it has just been converted into heat. Now, because this heat energy takes away from the gravitational potential and the kinetic, the ball bearing, which leaves our track at point A, will never be able to reach the same height. Okay? Because of the loss of energy, our ball bearing is likely to come to a lesser height. So it's going to roll from A all the way around to C, which is not as far up the track as where it began. So there are a couple of videos for you to watch, and I'm going to also attach a worksheet for you to complete and send back to me on Firefly. I will be on Teams throughout the period. If you want to speak to me, you can just type a message and I can add you to the voice call and we can have a class discussion. Okay, thanks very much.